Before we talk about any string searching algorithm, we need to discuss about the definitions of needle and haystack. What is needle? Needle is defined to be the string which is to be searched in the text, and haystack is the text itself in which string is to be searched. For example, let's say you have to search for the word Sectum Sempra in a Harry Potter book. Then the word Sectum Sempra would be needle, and the Harry Potter book text itself would be our haystack. Now let's look at naive string searching algorithm. Here let's try to make a setup in which always is our haystack and way is our needle. Now a brute force approach to search for way in all ways for a computer would be to try matching the letters W, A, Y against all the letters of always. We first of all start by matching W and A. We compare both of them and we see that they do not match. Since they do not match, we move the needle by one step ahead. Now we compare L and W. Since they don't match as well, we again move one step ahead. Now we match W and W. Since it's a match, we can match the second letter of the needle. Now since A is also a match, we can continue moving forward. Since we have exhausted the needle and we have found all three letters of the needle in the haystack, we can return true with the position of the haystack that we have found the needle in the haystack. Now we'll look at three more examples to see how it would work in each case. Let's say we were to search for wake instead of ways in always. Now similarly, A and W don't match, L and W don't match. Now W and W do match. A and A do match, Y and K do not match, so we move it one step ahead and start searching again. A and W do not match, W and Y do not match, S and W do not match. Since we have exhausted the haystack itself, we can return that the pattern doesn't exist in the string. Now let's look at another example. In this example, we have to search for the lower string AX in the string which is written above. Now if we start here, A do match, but X do not match. Now we can see the fundamental problem in this algorithm, that there is a lot of redundancy. If it were AX instead of AX, then we would see the problem even better. We reach till here and then we see X, but we move only one step and we start the whole process once again. This is very inefficient, and that is why naive string searching algorithm is not good. Now let us look at the time complexity which the searching algorithm uses. Let's say our haystack itself is of the order of magnitude n, and the haystack is let's say the haystack is of order O of n and the needle is of the order O of m. Then as we saw in this example, for each position we are searching for the entire needle, and then once it fails we are moving just one step ahead. Therefore the searching algorithm would be O of m cross n, because for each position in haystack we are trying for each of the n characters in the needle.